Good morning, team. Welcome back. I'm Corey, and we're hopefully about to finish up day 12 of Advent of Code in Rust. I took a break for almost 2 weeks, but I'm back and ready to go today. This is my third video for day 12, so I'm really hoping we can solve it today and move on. If you missed any of my previous days, check out the playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's get started. Okay, let's jump back into day 12. We're going to read over this a little bit just to remind myself mostly what problem we're working on since it's been a few weeks, and then we'll jump into our solution and see if we can debug what's going on. Okay, so this is called Hill Climbing Adventure, and the puzzle is basically that we have a hill that's represented by all these letters. You start at the lowest point, which is both the S and where all the A's are. So starting from the S, which is the same height as the A's, I guess, and you're ending at E, you can go up one letter at a time. So you can go from an A to an A, and then an A to a B to a C to a C, and then C to D. And so we want to find the shortest path through all the letters till Z, and you can only get to the end from a Z. So this is definitely a search problem. And for our small one here, the answer looks like this. You go from A to B to C, then down to D. You go over and then up, and you kind of like spiral around this until you get to the E. So this is our example input, which we should have over here. This is the example that yep, this is this one. And so we want to find the number of steps through it, and the path through this one with the fewest steps is 31. And if we look through our test here, we're actually going to turn off Copilot quick while I remember. So example input part 1, our example input running it through part 1 gets us the answer of 31. And it does, it passes. We also print out our path, which looks very, very similar to the path from here. There's a little bit of a difference right here where there's a square where we go right then down. This goes down right. It doesn't matter. It's a square of C's. We can get through it either way. And then this is exactly the path that we're getting for the example. But if we run it on mine, all I get is the answer 441. Which I know is not the answer because Advent of Code has told me it's not the answer, and I've asked a friend who also helped me confirm that it is not the right answer. Which makes sense. Like, I didn't think it was, but it's very confusing to me because we get a path, and our path through the input looks, moderately sane. It's definitely hard to see, but you get over to this area, and then you start doing some like loop stuff, and it's definitely finding a path through all of this, but I guess there's a shorter path that I'm just not looking at, and I think now we should just look at the code and see what we see. So this is doing an A prime search. I might refer to it as A star. But I think A stars maybe. Let's see, what is it? A star search. Which does it actually want to call this? Well, this is the video for it. What about the actual like article for it? A star. Yeah, okay. I might call it A prime. It's called A star though. So the idea here is that, well, one, we have our hill. Each hill, okay, so we have a mountainside, and each hill has a different thing. The heights map to U8s that are just by their byte U8 value, like ASCII values here. And then the directions, we have all of our directions. We have a mountainside, which is just a vec of a vec, just for storage. We have something that returns all the directions. We can go from a coordinate to a coordinate and get a direction from that. You do the x diff and the y diff, and you come out with a thing. A character is for printing it out. Okay, so let's go to our actual like part 1, and we'll work our way back up from there. Okay, so count steps from a mountainside. You start at a starting position, you go to a target position. There are no paths from, and there's nowhere to search yet. And a path from is a coordinate to a path from, where this is you came from this coordinate and the distance to get to yourself is this u size. So we start off with the paths from, you started from the starting position and it took 0 steps to get there. And then you search something. Yep, so then you search from the starting position. There is going to be something there. It's not our target. You look at the neighbors for a position you know how to get to, which is this. You know how to get to this position. And you say, is there an existing path? Oh, to search is different than paths from. Sorry. Okay, so we don't have a path from this yet at all. But we're going to add a search and say that the estimated distance. I don't think this is actually right, but I'm not sure that's relevant here. Because the estimated difference here is really like the starting position dot Manhattan distance to target position. And I think that makes sense because the next time we put something on to search, which is where we do here, we do estimated distance as our current distance plus the Manhattan distance. So I don't think this is going to matter because we're going to pop this off of to search immediately. So this shouldn't make any difference. Nope, still getting the same answer. For that one and for this one, yeah, okay. Didn't change anything. It shouldn't have. That makes sense. But this is more correct. Because our estimated distance is just the Manhattan distance at the moment. So we look at all the neighbors. We say, is there an existing path? The actual cost is the current position's estimated different. Wait. Current position is a to search pop. This isn't. Oh no, this is the estimated. Yep. But the actual cost is not the estimated plus 1. This isn't right. The actual cost to get to this path do I always need a... Wait, is this... Can I just unwrap here? Because is this else case not one that I can get to? Let's do it where I just do this instead. Panic. Can I get here? I want to see if this panics because I think it might not, which would be interesting. Example. No, we are getting here. Can I get here? Yeah, okay. So you definitely can't. That's interesting though. Okay, but I think that might be one reason. Paths from yeah, okay, well that makes sense. There's only one that isn't gonna have a, or let's see, paths from dot insert starting position and then, or what's it called, path from coordinate of, so path from has a from, which is the starting position and a current distance of 0. Okay, so if we do that, now can I hit this panic? I still think this is a little weird, but I'm not convinced that that condition is right. Okay, so why else would we get to somewhere where we don't have a path yet? Path from... Yeah, no, that doesn't... Yeah, no, we definitely... Existing path means we have another way to get to this thing. We might not have another way to get to this thing yet. Yeah, that makes sense. Because it doesn't... Yeah, we're searching the neighbors. Okay. Sorry. We're not searching the current position .c. We're searching the neighbors here, which makes sense. Okay, so if there's an existing path through a neighbor, we get it. The actual cost to get here is the actual cost to get here. Do I have the actual cost to get here? I don't think I do. In that case, the problem, right? Because the actual cost to get here. Do I need to add to search and act? That might work. Actual cost is a U size. We still just search based on the estimated distance, but I think I need estimated distance, estimated distance. Yep, that one's still right here. Actual cost here is 0, so that when we go to search, this isn't estimated, this is actual cost plus 1. New path dot current distance. What's new path? New path is a path from. Actual cost is new path dot current distance. Okay. Does that work for this one still? Haha, okay, okay, okay. Ooh, wait, did we get another answer? We got one that wasn't equal to 440? We got a different answer. We've got a different answer. Where's my answer? Oh. I wrote, this still says not equals. It equals, what's it going to equal? 425. Let's try 425 here. Well, I guess that's not the place to try 425. This is definitely going to give me 425 because I know it's passing. Okay, 425. There we go. Okay. Phew! That wasn't too bad. We got our day 12 part 1. Wow. Okay. Do all of these tests still pass? Did I break anything else? 7 passed. Awesome. Okay. So let's look at the diff here and figure out what was wrong. So I know what's wrong because we just fixed it, but let's talk through it. So in my search, in the to search, I didn't have how much it was actually costing to get from point A to point B. So that when I was looking at the paths for, well, this is, wait, I think also, well, it gave me the right answer. Let's try this out though. I don't think paths from needs this at the beginning. Does everything still pass? Yeah, okay, so that wasn't part of it. Let's go back to the diff. Okay, so but to search did need to know how long it had taken to actually get to the thing we searched for. That's important. This is just starting at a 0. That's important because actual cost here can't depend on the estimated distance to the current position. It's got to be the actual distance. And the reason that's important is because the estimated here has the Manhattan distance of things added to it. So we don't want to use the estimation as the actual cost. So we need 2 different values here. Okay, that's all we were missing. So then when we were using the estimated distance as the actual one, I think it just didn't see some shortcuts that it could take when we had the actual path. Because we're pulling things off based on the estimated distance, which makes sense, but then we don't want to use that as the actual cost down here when determining the path from and things like that. Okay, looking good here. Day 12, part 1, finally! Found the bug that was throwing things off. My A star was mixing up the estimated and actual distance um, when adding things to the to search queue. I don't like this thing because it doesn't. There we go. That'll work. Okay, awesome. Part 1 is done. Let's move on to part 2 now. Okay, continue to part 2. As you walk up the hill, you suspect that the elves will want to turn this into a hiking trail. The beginning isn't very scenic, though. Perhaps you can find a better starting point. To maximize exercise while hiking, the trail should start as low as possible. Evaluation A. The goal is still the marked square E. However, the trail should still be direct, taking the fewest possible steps to reach its goal. So you need to find the shortest path from any square at elevation A to the square marked E. Again, consider the example from above. Okay, so now instead of just always starting at the starting position, we're going to want to be able to start at any A. Now there are 6 choices for starting positions, 5A plus the S. If you start at this one, you can make it in 29 steps, so it's a little fewer. Okay. I don't think this will be too bad. Because this is just counting steps from somewhere to somewhere, but let's actually do this. Let's do count steps from the starting position to the target position. And then if I just like get rid of those and I make count steps here, do dot starting position, and then this is dot ending position or target position. So all we're going to do is we're going to make count steps take these in as args instead of doing it internally. Nothing should change up here. Awesome. And let's get an example part 2 ready. Example part 2. Example part 2. 29. Okay. Let's write a part 2 method. Okay, 2. So then I think all we really want to do here is we want to do like let starting positions equals mountainside dot. We'll just call like a method that doesn't exist yet. Possible starting positions maybe is what I want. Possible starting positions. And then from that, let's pretend it's already an iterator. So then we want to map over this for a coordinate, and then we want to do ms dot count steps starting from that to our target position, which let's just do this once. Let target position equals dot target position. Those are the max steps. And then we will just starting positions. Oh, okay, yeah. And then the answer though is starting positions dot map to the count steps, do a minimum, and then unwrap it. We don't need that line anymore. And we just need to implement possible starting positions. Okay, so then this returns an impl of an iterator where the item is a coordinate. Yeah, this just isn't what it's returned yet, but that is okay. So I think I just want to go through all of the possible coordinates and just filter and just look at them and see if they search for. What does search for do? Search for, okay, so that it doesn't do exactly what I want, but I could make it. So I think what I want to do is a function all chords. Yep. It takes a reference to self and it does an impl iterator, does basically the same thing we have down there where item equals coordinate. So what this is going to do is this is just going to do all of them. I could just make an array, but that wouldn't be very iteratory. I could just make this a vec, and it's not that big of a deal, but I kind of want it to be an iterator. I think I can do a from function one. Let's see if I can actually make this. Let's find out. Rust iter. There's a way to make an iter from a function that I think I might be able to make work here. So if you you do a counter outside, and then you do from. Okay, so like you do so like let mutable x equals 0, let mutable y equals 0. Um, now this isn't gonna be as easy. All coordinates is just gonna be a vec because it's just easier. Vec of coordinates. Um, let chords equals vec with capacity of self dot width times self dot height. So we just don't have to. This is just an optimization. I don't really need to. I could always just push things, but with capacity would be nicer here. What are like? Are these just different formats? They're eye sizes. As U size. Perfect. Okay, so then I want something like this. 4x, let's see, this is really just chords dot push C. That needs to be mutable. And this just then can be coordinates at the end. Okay, so now we have all coordinates, which is just an array of all the coordinates. And so in here we do self dot all coordinates dot into iter dot filter. And then I do, so this is a coordinate, and then self dot get a coordinate dot is valid starting position. Is possible starting position? Let's go possible. Starting position. That's all we need there. This I think needs to be a reference to C. No, oh, it's X. I just called it the wrong thing. And then it might not need to be a reference. Oh, consider dereferencing. And then this I need to implement. Generate the method. It's a Boolean. Yep. Okay. Self dot height equals a. Perfect. Okay. And then what's the issue here? Hidden type consumes lifetime, captures it. You can add an explicit. Is it there? Nope, it's there. Perfect. Okay. Um, that might be all I needed for part two. Part two looks like it's gonna compile. Is it gonna run? Woohoo! Part two successful. Awesome. So there's a debug happening that I think I can just remove here. Debug? Oh my gosh, I'm recording. There we go. Debug. Print line? Print path. Okay, so where's print path being called? Self.print path. There we go. Just comment it out. Okay. But that wasn't very relevant. I just wanted to see that a little nicer. Okay, and let's do part two with my input. And maybe be able to wrap up pretty easy here today. My input, it's not going to be 29, but hopefully it's going to be the right answer, which is... Ooh, we unwrapped a none value. Ooh, awesome. 261. Where is 261? Ooh, it's when we are trying to get the actual path here. And paths from don't get okay, so let well, I guess I don't want that. I just want to debug out current. Let's see what that does. Okay, so the last one was 9120. Okay, so we will take a look at that. Okay. So 9120 was the last one to come out of this here. So we're counting the steps. Why would we not have a path from? Like, I guess I kind of want to print out the whole paths from here, but that's gonna be a lot. But let's try it and just see what happens. Oh, it doesn't like that oops. Didn't take a reference in my debug, which I always find annoying. I kind of wish the debug macro like always took a reference for me. Uh-oh. Okay, well, while this runs, I am going to run real quick, and I'll be right back, and hopefully this test will be finished. Back in a sec. Okay, I am back, and this test is still spinning, so we're gonna need to make this take a little less time. Okay, so this is, though, in here where we were debugging out paths from and current. Let's I want to print out current again so that I can figure out which path, which coordinate, I mean, is the one that it's blowing up on. 9121. Okay, so then I think what I want to do is only output paths if it equals that. If current equals a coordinate 9120, then we want to debug out the paths from, so this is still going to be massive, but now we'll at least only get one instead of a million of them. Awesome. Okay, so here's our whole hash, and we were at 9121. And there's just lots of coordinates. Does paths from here happen to use the start? Oh, it doesn't. It uses starting position. Oh, interesting. And actually, I guess the other thing that I want here, and maybe this is more helpful, is I actually want actual path here. I want to see if we've done a path or whether we're at the beginning of a path. That actually is probably going to be more useful than the whole paths from. Because I think it's going to be empty. Actual path. Yeah, so it's the only thing in our path right now. And then paths from is blowing up, while current does not equal starting position. Oh wait, 9120. Is that the ending position here? 9121, 91. Yeah, 9120 is the ending position. Okay. So is it saying we didn't find a path to that? So I guess the path here would be like, if let some previous equal paths from dot get the current one. Okay, so that let previous equal previous dot from actual path dot push previous, oops, and then current equals previous, else return max. I don't know what I'm returning, usize max, I assume. Usize max, yep. Usize max. Because what I really want to turn is something more like none, saying that there isn't one here, but for the moment, returning a really high number is going to be good enough, I think. Nope, now we infinite looped. Now we're just at 0 and 1, and we're just looping. If no, if we oh yeah, okay. Yeah, that's fair though. If there's not a path from the target position. Okay, but let's also get rid of some of the debugs that I added, because I think they're just confusing me. But this is still just, oh wait, I know this infinite loop, so I do need something. Zero, 1, 0, 1. We just keep looping on that. Like, do I want something out here instead? If paths from dot get the target position dot is none. Debug out, no path found. But then we just return the U size max. Let's try that. And we're just looping more. Okay, so we don't print that. It looked like ever. We're just looping. Okay, so if we're just looping, how many assert equals starting positions dot count length? This is just a freaking it's a iterator, so it's not gonna know how to do that easily. That's moderately annoying, but it's okay. I guess I could test it, right? Because I have the method. Yeah, okay. I could write a test for it. But that's not really what I was actually trying to look into. I'm infinite looping here because of the thing I added. Where am I? Yeah, okay. The thing I added is this, where if you don't, this was an unwrap. So if you don't have something, I'm just gonna say that we're returning max from this whole thing. And I shouldn't actually get into here anymore. Now I should be able to go back to just unwrapping here. Because I should have made it so the only time... Oh, wait. Was that still happening there? Oh, it doesn't matter, but it was doing that. Because now this is happening here. There's no path found. We just return earlier. No path found. Oh, hey, look at that. We got an answer. 418 is our answer. Okay, so I think that was it. I was blowing... the no path found was giving me an issue, and then my fix for no path found was not the right answer. So this should really, though, return an option of a U size. So I think I'll probably fix that, but let's see if this works quickly. So this was supposed to be, what was it? 419? 418. Oops. Got a behind the scenes peek here. 418. Okay, awesome. Day 12, part 2 complete. Finally. Only took us about half an hour today, which was great. Oh, we're back to here. Sorry about that. Okay, but let's first of all do this. Make this 418. All of these tests should pass. That no path found prints out a lot, but it does work. Let's get rid of that. Tests still pass. Look at that. Okay, and then the last thing that I want to do here though is I I don't like this returning a max. This is returning the wrong thing. This really wants to return an option of a U size. And the reason for that is so that here I can do a sum. You actually have a thing here. And in this case, we can just return none. But now all my usages are going to be wrong. And by all my usages, I mean like the two of them. This one, we're just going to unwrap, expect. We expect there to always be a path for part 1. And then in part 2, this is actually just going to be a filter map, and everything will be better. Because what filter map does is it does both a map and a filter. So if you get a none, it just gets rid of it. And so count steps has the perfect return type for that. And look at that. Everything still passes perfectly. How does everything still pass perfectly? Oh, because part 1 and part 2 do the unwrapping to get the things, and the filtering happens here. Okay, awesome. Yep, there's the expect there. And that was nice and easy. So let's do day 12, part 2. Pretty straightforward after the first half. Straightforward after part 1. Just looping over multiple possible starting decisions. Okay. And there we go. That is... Oh, let's push these up too. Might as well. Oh. Got my YubiKey that time. Okay, so that was finally day 12, part 2. I'm glad I tried again today, and happy with the results. Thank you for tuning in, and hope to see you back for day 13 here very soon. Thanks. Bye.